Okay, so in order for me to find this, the useful life, I would use my calculator, which will pop up here in just a second, and find where these two are equivalent, because at that point, when revenue equals cost, then that would be the end of the useful life, because after that, cost would exceed the revenue. So let me go to y equals. I'm going to use X instead of T. So the first one's my cost. So 5x e to the negative x squared. Let me see if I can tell anything from this graph. So that's cost. Now see the red coming in. All right. I think I'll go to Zoom 4 to get a better picture. Again, there's my cost function. It is a straight line. And there's my revenue. Now, this part over in here, remember T in this particular problem is time, so this does not make any sense. It starts at 0, so my lower limit here would be 0, and if you'll notice, this is above my cost until right there, and that's an intersection point. So if I do second calc number 5, and move my cursor over there to where it looks like it's at the intersection. My cursor will keep moving, I hope. Thank you. And when you do intersection, once you get it to where the two lines cross, you hit your enter 3 times until it comes up with the word intersection. And my useful life here to the nearest year, and I'm after the X, remember this is time, would be just 2. So that's one part of it. So let me move this out of the way. So for 75, lower limit is 0, upper limit 2. So we found the useful life to the nearest year. And then it says, what's the total profit accumulated during the useful life of the machine? Well, for me to find profit, remember that is revenue minus my cost. Now guys, since you are all on here on a application problem, what I want to see, this is called the integral setup. Lower limit, upper limit, what you're doing with your particular problems here. In this case, I'm finding my my profit, excuse me. And then whatever your independent variable is, we always have that D whatever at the tail end. Once you find the setup, the next thing I'd like you to do is use your calculator, because the hard part on this one is this setup. The problems that I ask you to integrate, like those that were in section B, not the applications, yeah, I do want to see all your work. So the next thing on this one, now I can't use this because when this thing graphs, it has to be with respect to the x-axis. So let me go back to y equals. I'm going to clear that one off and go down to this one so I can put in the rest of this. So I'm going to put in subtract 1 divided by 11x. You ask it to graph. And remember, I'm only interested in this part from 0 to 2. So what I'm going to get to shade is that part right in there. So second calc number 7, 0 is my lower limit, 2 is my upper. So what is the total profit accumulated during the useful life of the machine? And it doesn't really say it around anywhere. I'd go say 2.27, but that's in thousands. So Derek, what you think?
I didn't even think about using the calculator. I was trying to do it by hand,
I'm
and
sorry.
I kept getting things the wrong answer on the second part. I always got the
Useful life.
the useful life. I just couldn't get the total profit on that one.
Well, if you did it by hand, you could. This part, the second term's not that bad. This term here, the one with the E, you'd have to use the U substitution.
Yeah.
Now, do you want to see that, or you all right with this?
It depends on whether I'm going to have to we're going to have to have a question like this in any quizzes we have that we have to write it out.
Well, the thing is, though, if it's an application problem, a word problem, then, like I said, if it's on the test, I want to see the setup and then use your calculator to solve.
Okay. Then I don't need to see the steps, I guess.
Okay, there is a problem I want to look at, and it's problem 71 up here. I guess the biggest thing is I want to see the setup for it. We've got a new piece of industrial equipment, will depreciate in value rapidly at first, then less rapidly as time goes on. Suppose that the rate in dollars per year at which the book value of a new milling machine changes is given approximately by this function, where V of t is the value of the machine after t years. So what's the total loss in the value of the machine in the first 5 years? I'd like you, let me turn my paper around. So I know it's going to be 500 t minus 12, and that would be dt. I'd like you to figure out the lower and upper limit. It's not the problem, this problem itself. It's figuring out the lower and upper limits on this. What's the total loss in value of the machine in the first 5 years? What should be my lower limit?
Lower limit 0, upper limit 5.
Yeah. I've had people tell me 1 here, but the only problem with 1 is you're not considering 3 months or 4 months or 5 months. 0 is the initial time that the machine was purchased. So this would be for the first 5 years. I usually have people get the second 5 years, but it's always this one up here that throws them for a loop. So that would be my setup. I want you all to use your calculator and see what you come up with on this. Now, it's all right that you don't see it, just knowing that it's there. But this one would have a y-intercept of, oh my goodness, 0, that would be negative 6,000, I believe. So you don't have to see it, but it is there. And that is what I came up with on my calculator. Did anybody else get that?
Yeah.
Yeah.
23,750.
Mm.
And it says that this was in dollars. Now, if I go back right now and get the second part of it, it looked like that the whole thing is shaded, but I did tell it, if you notice, right under my answer, the interval I want it to do is 5 to 10. So see if you come up with that on that second part.
Yep.
It is negative because if you'll notice up here, it depreciates, and depreciates indicates a negative value. So that is depreciating by $23,750. So I would not go, it's depreciating by a negative amount. That negative indicates the depreciation. But again, this very first one, that's where I have a lot of people sort of have issues. I'll put it that way. So are there any other problems you might like to see? Well, has anybody had a chance to look at 13.1?
Not yet.
No.
No.
Well, let me open it up to chapter 12 itself, because you've got to have your quizzes done by Sunday for that for those particular that particular chapter. So anything 12.1, 12.2, 12.4, 12.5. So we okay?
I guess.
I guess. As I saw 3 of y'all did some of your quizzes. At least, let me see, the first 3 you have. And they weren't too bad, were they, guys?
No.
I actually have a question about that last problem you did on the calculator.
Okay.
How did you enter that into the y equals?
This one right here.
Yeah.
I never use, if it has a different variable than x with respect to graphing, it has issues. So I always use x regardless of what variable they use.
Okay, I was trying to put the math 9 into that section. Okay, that's why I was messed up on my.
Well, the
graphing.
math 9 is if you do it without graphing. So
Right.
let me look at math 9. And you've got the old operating system, right?
Yes. Mm-hmm.
Or let me not say old, I'll say classic.
Yeah. Both old.
So math 9, you first put in your function. Use a comma. Then you have to tell it d whatever, and that's you put the dx here, but you don't put dx, you just tell it x,
Mhm.
comma, and always lower than upper. Because what's nice about this one, since I had that other one, if I do second enter, cursor back in, change those particular values, it's even fairly quick that way as well.
Okay.
And that works, those of you that do have the new operating system, it does the same thing. You can cursor back and change what you need and just press enter. You don't have to cursor out. So we okay?
Yeah, I think so.
Now, I'll look a little bit at 13.1. This is an old print off. It used to be, they left out one chapter in the book, so it threw everything after that one chapter off by one. But finding area between a curve and the x-axis, technically you have been doing that, but when you see this word area, finding the actual area, it must be positive. You have been evaluating in 12.5, so you could come up with negative values and those type of answers. In this first situation, if you'll notice, my curve is completely above the x-axis. And if you think about a rectangle here, remember that is dx, which is always positive, and my height here would be a positive y value. So from A to B, it would be from A to B, f of x dx, and it would come out to be some positive answer because everything's completely above it. Now, where we run into issues is something like here in example 2. Let me refocus here. That's better. If I go from A to B, notice right here, I have got a 0. This is where my curve crosses the x-axis. What you saw in 12.4 is anything below was negative, anything above was positive. But if I must find the area, anything below, I have to make it positive. So this is where one of those rules comes in that I initially talked about the other day. I'm going to have to find this area here and then turn around and find this area. But with this area being positive, that's not as much work as I need. This is the one I have to take care of. And there's a couple of ways I could do it. One way, if I go from A to C, and if I multiply my answer by negative, that would make that particular area a positive. The other way, which I do like, and I'll show you why in just a bit, is if I take the absolute value. If I take the absolute value, that would make any negative part positive. So it's a sort of taking, doing two integrals, but there's not that much work. Now it says either one of these is acceptable, but since in this example, from A to C lies below, you're going to have to fix it. So your first job when you're asked to find the area is you're going to have to graph. You need to make a nice picture and know from where to where that you're going to have to take the area of. Now let me look at this example. If you graph this, now I changed my window on this. It looks like my x-min's a -2. X max is a 5. This is probably a 10 here and 1, 2, 3, and -4 there. So this window is changed somewhat. And if you graph this on your calculator, even using a Zoom 6, you will still see from -1 all the way to 1, 2, 3, 4. This is what they want me to find, the area. I need to find this 0, and I think it should be 1, but remember you had to find zeros in the last section. So let me graph this. So I've got -1 here, and I've got 4 here. So I did just go in so I could have a prettier picture. But I need to find this 0 since it crosses between my lower and upper limits. So second, trace 0. So 0 and 2. So my 0 is 1. I need to know that. Now these are my two options. As long as it's above, I can go from -1 to 1, and it's all right because this will give me a positive value. I could subtract because right now this is negative, and if I subtract it, it will change it to positive. Or I could do it using the absolute value. So that's what it should come out to be. We're going to see. Let me get a sheet of paper. Because I'm going to start right here. I want to integrate it first, and then I'll show you what we're going to be doing. Notice that this and this, you got to look to see what my thises are the exact same thing. So I only have to integrate once. So I've got 1x, add 1. And I want to clean that up somewhat. So that's the one I'm going to focus on. So is that okay so far?
Yeah.
Now, taking into account these two, for the first one, I'm going to let x equal 1 minus x equal -1. Add on, let me do absolute value bars here. This one will be x equals 4, x equals 1. Guys, you only integrate once, but I have to take care of this one. So that's this piece. And then this one, and that would be that piece. So in a way, I've got two separate problems, but I'm using the same antiderivative for both. Now this is where I get my calculator and I start substituting in like I've done before. Let me store 1 in, type in my function. So I've got 7/3 on this one. Did anybody else get that?
Yeah, I got that.
But if you look, I've got x equals 1 here and x equals 1 back here. So technically, I've only got one additional one that I have to do because there's going to be a repeat. Where this one leaves off, this one picks up. So let me find the other ones. And let me know if you're okay with this. Is everyone all right so far?
Yep.
Yeah.
Okay. Now my red box, I'd have 7/3 plus 25/3. So that would give me 32/3 plus absolute value. It looks like I've got a negative 20/3 minus 7/3. So that would be a negative 27/3. Absolute value of a negative is a positive. So that would give me what? 59/3. Yay. Okay, good. I am going to find the decimal approximation because I'm going to show you something here in just a second. See if you're all right so far.
Yeah.
Tyler, you're here, aren't you?
Yes.
Okay. Now, let me get my calculator. But I'm going to do something with my calculator. So I need you to go to y equals. Is everybody there?
Yes.
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 Now, because part of my curve is below, in order for me to check on my calculator, I need everything above. So I'm going to put absolute value here. Absolute value, if you go to math, and it's over under number, my very first one. Now, Derek, when you get this, you'll get the ABS in parentheses. I
Yep.
change this back to the math type, and I just get an absolute value.
Okay.
I'm going to type this in. And Derek, all you have to do is put a parentheses at the end. So is everybody all right so far?
Yes.
Now you know what absolute value does. It makes it positive. So if there's any, when I put in an X value and it comes out negative, when my Y comes up, it's going to make it positive. Pretty much it's going to remind you of a tennis ball. So let me ask it to graph. Sorta. This is sort of like a tennis ball, but tennis balls normally don't take off like that. But the thing here is everything's above the x-axis. So now I can do my second trace for the calc menu, number 7, and my lower limit on the original problem was -1. Yeah. Upper limit 4. Now, our answer is more exact than the calculator, but I mean, if you'll notice all the way down to the 4th decimal place, we're okay. The calculator does not integrate like we do. It uses some of the method, you know, like the rectangles, but it uses millions of them, but it's still going to be off. But this is a way that you can check yourself. But the first thing, if you see area between curves that you're going to have to do, then you're going to have to graph. Make a rough sketch, know your lower limit, your upper limit, and if any part of that curve is below the x-axis, you're going to have to fix it. So what do you think?
Not too bad.
You're still doing pretty much the same thing, but instead of just evaluating, you have to find the area, and area is a little bit special in that you're going to have to get a picture of it. So let me see what else is on here. And this is what we did about absolute value, where it's found. Now, if you have the new math type, you will actually have absolute value. But Derek, any of y'all that have an 83, end with a parentheses with your function.
Okay.
Now, let me say a little bit about this next part. When I actually have two different curves, whatever you put in Y1 will graph first. Whatever you put in Y2, it's going to graph second, and so on. But it says when you find the area between curves, the region must be enclosed. Sometimes you'll be given the interval for which you must account for. Other times the two curves intersect. So you're not given the interval, and you have to see where the two curves hit one another by using the intersect command on the calc menu. Now in this particular problem, I graphed them here. I did label. In your calculator, it doesn't label. So that's why you've got to watch your calculator. Now in these particular problems, if you'll notice, I've got one curve, I've got another curve, but they give me an interval. So again, a rough sketch you'll need. So I want to go from 1 up to 4, and it must be enclosed. They want the area between the two curves. And sort of like what we did in that question, Derek, that you asked about the useful life. Remember when we found our revenue, our profit, we had to do revenue minus cost, and
Yes.
that gave put my curve completely above the x-axis. The same thing here. Remember my revenue curve did something funky like this, and then my cost curve came in like this, and we were after this part. But the function we put in was revenue minus cost. And it's fairly simple to do these. You already know your values. But when you set them up with respect to each other, you always do the curve that's on top minus the one that's on the bottom. Always. Because that will put it completely above the x-axis, which is what I want. Now I did leave some steps out in here because I was running out of room, but this is top curve minus bottom curve. So that pretty much is what you need to remember to do. So when you're asked to find area, the first thing you do is graph it. Look at the picture. Look at the interval they give you that you have to deal with, and see what curve's on top. So you might look at this particular video. There are a few more problems that I talk about over here. I've got 2 more examples with graphs. So on, let's see. On Monday, we take a bigger look at 13.1, but it would be nice if you would, you know, do some problems so you can have some questions to ask. All right? Does anybody have anything right now?
No.
Daniel, you all?
No, I'm good.
You're good?
Yep.
Well, I hear my kitten at the door. He's wanting in. He'll start scratching at the door here in a minute. Well, guys, if everything's all right now, then remember, get those quiz done on Sunday, all of chapter 12. Your 13.1 quiz, it won't be due until the 23rd. And that will be after the review on the 22nd. And I'll print off the review in my math lab so we can look at it and see if you have any questions. So for Monday, be ready for 13.1, any questions you have there. And then Wednesday's important because that's when we're going to do our review. Because originally your test was going to be due on the 24th, I think. I don't even know where that calendar is anymore. But after the review on the 22nd, then I will open the test up right after our review. So it has to be done or completed by the 27th. So we won't have class on the 24th or the 27th, if that's all right with you all. Hello?
Yeah, that's good.
Yes.
You all right, Peyton? Okay. Well, guys, I guess that's it for right now. And we're almost done. I only have
That's
one more
good.
section to do.
Yay.
Okay. All
So
right.
take care. Work hard.
Y'all have a good one.
Bye. Bye.
Bye-bye, guys.
Bye.